All right, guys, so this is the impulse and momentum review. So I'm going to go over the review sheet on the back pages of your packet. So the pages 25 and 26 on your packet. But first, I'm also going to go over a couple pages from within the packet. So pages 10 and 11, and then I'm going to do pages 15 because that's got a graph on it. So these are some things I kind of want to do just to kind of give you more practice on that in case you need that. And then we'll do the review thing last. This video shouldn't take long. But first, I'm going to go over basically the equations you're going to need for this test. Okay, so let me turn my pen on first. So first equation that you got in this packet was for momentum. Okay, so momentum was characterized by P. So we had P equals mass times velocity. Okay, so P was momentum, M is mass, V is velocity. So this can also be written as change in momentum equals mass times change in velocity. I usually keep it as this. I just do VF minus VI. Okay, so that was your momentum equation. Then you had your impulse equation. So impulse was characterized by the letter J, and that was force times time. Okay, so impulse and momentum are basically the same thing. So impulse is just change in momentum. So that's why we can set them equal to each other in the impulse momentum theorem. So that's why we can say Ft equals mass times velocity, or Ft equals mass times Vf minus Vi. Okay, so those are basically your basic equations for this test. And then we're going to go over the actual conservation of momentum. I'm going to save those for last because I want to kind of talk about those and their equations. So we're just going to stick with these first. One thing you can also write down is for the graph part of this review, there's really only two equations you really need for that. And that's going to be the P equals M times change in V. Okay, so VF minus VI. And then we have the acceleration on the graph, which is just A equals F divided by M. So this is just for the graph part. So if you want to write these down, that'd be a good thing to have. So let's do some practice first. Just kind of getting into it, the basic stuff. I don't know why this page 10 kind of came out blurry, so just kind of bear with me on this. So page 10 in your packet, the impulse and momentum worksheet. So we're going to kind of start off nice and simple. And I like to underline and label things as I go. So number one, I have a force of 10 newtons. Okay, so I'm going to underline that and put F right above it. So a force of 10 newtons towards the north acts on a body for 5 seconds. So I have T. What is the impulse? Okay, so impulse is J, and I know J equals F times T. So my force was 10 newtons, so I'm going to put that in parentheses. And my time was 5 seconds. So 10 times 5 gives me 50. And my units for impulse is just newtons times seconds. Okay, part B, this is where a lot of people kind of get tripped up on. It says, what is the momentum change of the body? Okay, impulse is change in momentum. So that's why we can say J equals P. Okay, so momentum is the exact same answer. So P equals 50. Momentum's units are kilograms times meters per second. Okay, so that would be your answer right there. So I think that was one question on a quiz is what are the units for impulse or momentum? Okay, you can do it both ways. You can have newtons times seconds, or you can have kilograms times meters per second. Okay, so moving on to the next part. If the body was originally at rest, so I watch out for terms like this, at rest, that means my VI is there. It has a mass of 2 kilograms, so there's my mass right there. What is the final velocity? So that means VF is my question mark. So I have a mass and 2 velocities, so if you look at your equations, okay, we have P equals M times VF minus VI. Okay, P we already know, we already found that. Okay, we already found that, so that's 50, so 50 equals my mass, which is 2 kilograms, times VF, which I don't know, so I'm gonna leave it as that. And my VI is gonna be 0 because it was at rest, so VF minus 0. So 50 equals 2 VF. So divide both sides by 2, and you get a velocity of 25 meters per second. Okay, so this is why I usually like to write out this equation all the time, is because if you have two velocities, that's a dead hint to use that equation right there. Okay, number 2, I have a golf ball with a mass of 10 grams. Okay, so here's my mass right here. First thing, I'm just gonna write over here, mass equals 10 grams. I don't want 10 grams, I want kilograms. So if you wanted to convert it to kilograms, just divide by 1,000. So 10 divided by 1,000 is gonna give me 0.01 kilograms. Okay, so make sure you convert that to kilograms. So grams is no bueno. After the impact, the ball moves off with a velocity of 50 meters per second east. Okay, so I have my velocity, 50 meters per second east. I don't know if there's gonna be another velocity yet, so I'm just gonna leave it as V. If the ball and the club were in contact for 5.0 times 10 to the negative 3 seconds, so there's my T. What is the average force acting on the ball? Okay, so that means F is our question mark. Okay, so if you notice here, I have F, I'm looking for F, I have T, I have M, I have V. So that should be a dead giveaway that I'm gonna use this equation. If I have that many numbers, I gotta use a big equation, and that's the FT equals MV. Okay, and since I only have one velocity, I don't have to worry about the VF minus VI. So I'm just gonna leave it as that. So force, I don't know, so I'm gonna leave it as F. My T is 5.0 times 10 to the negative 3 equals mass. My mass is 0.01 kilograms times my velocity, which was 50. Okay, so I would multiply 0.01 times 50 and then divide both sides by 5.0 times 10 to the negative 3. Just be careful when you put this in the calculator. If you're going to do the times 10 to the negative 3, just make sure you put that whole thing in parentheses. So put this whole thing in parentheses, otherwise your calculator can get confused and you may get a wrong. Even though you did it right, you may get a wrong answer. Okay, so you should come out in the end, it should be a force of 100 newtons, and that would be your final answer. Okay, so again, if you get mass, velocity, time, and you're looking for force, or you're looking for one of those, okay, that should be a hint that you're gonna use the big equation because it has all of those factors in it. Okay, so number 3, I have a 2 kilogram ball moving with initial velocity. Okay, so I have a mass moving with an initial velocity of 3 meters per second to the right. Okay, so my VI, and then watch out for these directions right here, so to the right. So since it's the first thing, so the first direction, I'm just gonna say right is positive. Doesn't matter if you said it was negative, that's fine. But I'm just gonna stick with the first direction being positive. Is acted on by a constant force to the left. Okay, so that means my force is coming to the left for a period of 3 seconds, so that's my T. After the interaction, the ball is moving to the left. Okay, so moving to the left, so I'm gonna say left is negative. Okay, since right was positive, left has to be negative. And I have a speed of 6 meters per second. So that is my V final. Okay, so determine the force. So we're looking for F. So that's my question mark. So I am looking for F. I have M, I have 2 V's, I have T. So this is gonna be F times T equals M. So since I have 2 velocities, I'm gonna make sure I do VF minus VI. Okay, so force I don't know, so I'm gonna leave it as force. My time is 3 seconds. My mass is 2 kilograms. My VF, so this is where you gotta be careful, is your final velocity was coming to the left at 6 meters per second, so this is gonna be a negative 6. Minus your initial, which is gonna be a positive 3, so negative 6 minus 3. Okay, so you have to really be careful with directions. So pick one to be positive and pick the other one to be negative. Okay, so I'm gonna clean this up a little bit. So this is the same thing as saying 3F equals 2 times, so negative 6 minus 3 is negative 9 times 2, which would be negative 18. Okay, divide both sides by 3 and you get a force of negative 6 newtons. So it is okay that this is negative because remember the force was going to the left. So that makes sense that it's gonna be negative. Okay, so moving on to the next one. You push an object with a force of 3 newtons east for 5 seconds. So I have force and I have time. What is the impulse? Okay, so impulse is J. Okay, this is gonna be a simple, just J equals F times T. So J equals 3 times 5. and that gives me 15 newtons times seconds. Okay, number 5, what is the impulse on an 8 kilogram mass, a chain, I think there's a little typo there. What impulse gives an 8 kilogram, sorry, I just read that wrong. What impulse gives an 8.0 kilogram mass a change of velocity of 4 meters per second north? Okay, so I have mass and I have velocity. Okay, but it says impulse. Impulse is usually characterized as J, but remember, impulse and momentum are the same thing. So I can just still do this equation, P equals M times V. So my mass is 8 kilograms, my velocity is 4. So that means I have a momentum, or impulse, same thing, of 32 kilograms times meters per second. Number 6, suppose you throw a ball against a wall and catch it on the rebound. How many impulses were applied to the ball? Okay, so impulses is change in momentum. So the ball had to be sitting still, and then it was thrown, so there's 1 right there. Right when it was thrown, there's 1. Then it hits a wall and changes direction, so it's going to hit the wall and go back, so there's another impulse. And then whenever it's caught here, so whenever it hits my hand and stops, there's the third impulse right there. Okay, so that means there were 3 impulses acted on this ball. Which impulse was greatest? Okay, so the one that basically took it from a positive to a negative. Okay, so that means the wall was the greatest impulse because you had a positive velocity changed to a negative velocity. Okay, so that was pages 10 and 11. So now what I want to do is, because the review, we'll go back to the review page, but the reviews graph was pretty simple, and I actually wanted to pull one from y'all's packet to actually have a little more depth to it, okay, and kind of explain it a little more, because in case you see this on the test. So I see a graph here, so there's a force times time graph, okay, so that's force times time is impulse. So if I were to ask you what the impulse is, this is when we need to find the area under the curve. So this is how I do it. If you want to do it in polygons and stuff like that, I just separate it into triangles and squares / rectangles. Okay, so mine would look like this. So I'm gonna make this first segment triangle, then this segment's gonna be a rectangle, and then I'm gonna bring this down. But I don't want to leave it as that. If you want to leave it as that, it's fine. But I like to separate it just into triangles and squares and rectangles. Okay, I don't know why, it just visually looks better to me. So I'm going to separate this. So I've got that big rectangle and I've got that triangle there from 7 to 8 seconds. Then I'm going to go ahead and separate this into a triangle. And then lastly, I have one more rectangle at the end. Okay, so in order to find the area of a square, okay, hopefully you kind of memorize this, the area of a square just equals base times height. And then the area of a triangle is 1/2 base times height. Okay, half of a square is a triangle. So I'm going to go through it. Before I even answer questions, I'm just going to go ahead and find the areas for all my little segments. So the first one, 0 to 2 seconds, so my base is 2, my height is 10, so 2 times 10 is 20, but since it's a triangle, we're going to do half that, so you should get 10. From 2 to 3, I have a base of 1. My height is 10, so 1 times 10 is going to be 10. And then I have a base of 3 to 5, so that's 2. And then my height is 10, so 2 times 10 is going to give me 20. Okay, this next triangle, I have a base of 2, so 3 to 5 is 2. And then I went from 10 to 20, so my height is 10. So 2 times 10 is 20, but half of that, since it's a triangle, is 10. Okay, I've got this big rectangle here. My base is going to be 2 because I went from 5 to 7, and my height is 20. So 2 times 20 gives me an area of 40. And then my last triangle up the top, on the top is going to be a base of 1 and a height of 20. So 1 times 20 is 20, but half of that is going to be 10. Okay, then we have our bottom side. These are going to be negative. So we went from 8 to 9 seconds. So my base will be 1. And then I went from 0 to negative 20. So 1 times negative 20. And half of that, since it's a triangle, so negative 10 is this triangle. And then this rectangle here, I have a base of 1 and then a height of negative 20. So 1 times negative 20 gives me negative 20. Okay, so that's my first step I do every time before I even start answering questions. Okay, given a 5 kilogram object, so they gave me a mass, is moving with initial velocity of 2 meters per second, so this is VI. Okay, so there's a chance you may see something like this where it has an initial velocity of 0, which would just honestly make things easier. Okay, but you'll see that here in a second when we start doing the actual math, but for now they gave us initial velocity. So we'll just go ahead and do the more difficult one. If you have initial velocity of 0, then it's going to be a little bit easier. So what impulse is given to the object in the first 8 seconds? Okay, impulse slash momentum equals area under curve. Okay, so impulse slash momentum is just the area under the curve. So in the first 8 seconds, we would just find the total area under that line. Okay, so from 0 to 8, I'm just going to add all that up. So 10 plus 10 plus 20 plus 10 plus 40 plus 10, and that gives you an impulse of 100 newtons times seconds. Simple as that. Okay, if it was said this is first 7 seconds, you would have just stopped at 7 seconds. Okay, you just add up until they tell you to stop, basically. Number 2, what is the total change of momentum of the object in the first 10 seconds? So even though we had impulse here and momentum here, there's nothing different. We're just adding up the areas under the curve. So in the first 10 seconds, so that means we're just gonna add up the whole thing. So the first 8 seconds was 100, so instead of me doing all that math again, I know the first 8 seconds was 100. So 100 minus 10 minus 20. Okay, so that should come out to 70 newtons times seconds. And that's it. That's all you had to do there. Okay, so number 3, what is the object's velocity? So remember on the equations I had y'all write down for the graph part, we had P equals M times VF minus VI. Okay, if we ask you for the velocity, this is the only equation you need. So you can write this down and keep it under the graph only section, whatever you want to do. So we want to know what's the object's velocity at 2 seconds. So that means we're always looking for VF, basically. Okay, so in the first 2 seconds, P, so you would find the total momentum up until 2 seconds. So if you come back up here, from 0 to 2 seconds, I have a total momentum of 10. So you're going to set P as 10. My mass, they already told me, was 5. VF, I don't know, so I'm going to leave it as VF. And my VI was 2. So this is where it would be easier if you were starting from rest, because your VI would just be 0 and you wouldn't have to worry about it. You just put in 0 and that'd be done. Okay, so 0 for VI. So I'm going to simplify this out a little bit. So 10 equals 5 VF minus 10. Okay, I just cross multiplied. So I bring that negative 10 over to the other side, and when it comes over, it becomes a positive. So this is now 20 equals 5 VF. Now I got to get rid of the 5 attached to VF, so I'm going to divide both sides by 5. And I get a final velocity of 4 meters per second. Okay, so that's my answer right there. So right here, I'm going to put right here, even though this might kind of get in the way. I'll write this over here so I have more room. Okay, this is the only thing that changes. Okay, P is the only thing that changes in this equation. Okay, so we can do this 4 times, and the only thing that's going to change is P. Okay, M is going to stay the same. It's still a 5 kilogram mass, and VI is always going to be 2. Okay, so let's do B just to show you. So I need to know my momentum up until 3 seconds. So from 0 to 3 would be 10 plus 10 is 20. So now P is 20. My mass is still 5. VF I'm still looking for, and my VI is still 2. Okay, so 20 equals 5 VF minus 10. I bring that 10 over, becomes positive, so this now becomes 30 equals 5 VF. Divide both sides by 5, and your final velocity is 6 meters per second. That's it. So I don't have to do all of these, but you kind of get the point now. So just add up the area under the curve until the time they told you, okay, and set that as P, and then you know mass, and if we give you initial velocity, just plug it in as VI, and then if it was 0, so if you're starting from rest, This 2 wouldn't be here, so you would just put 0. So it would just be 5 VF. Okay, so that's how you find velocity on this graph. Acceleration's even easier. Okay, all we have is this equation right here. A equals F divided by M. Okay, so at 3 seconds, all you have to do is find the force at 3 seconds. So at 3 seconds, I'm right here. Okay, if you look over here to the left, my force is 10. Okay, so my force is going to be 10. My mass, they already told me, is 5. So 10 divided by 5 gives me 2 meters per second squared. That's my units for acceleration. So my answer would be 2 meters per second squared. That's it. At 8 seconds, so if I look at 8 seconds, I'm right here. I look over here to the left, and my force is 0. So this one's going to be even easier. Okay, my force is 0. My mass is still 5. So 0 divided by 5 is going to give me 0 meters per second squared. Okay, number 5, what is the object's final velocity? Okay, this is the exact same thing we did up here in number 3. Okay, we're just doing the total thing now. Okay, so we're still using P equals M times VF minus VI. Okay, so now we're using our total, which was this right here, 70. So P is now 70. My mass is still 5, nothing changed there. Still looking for VF, and my VI is still 2. So not a whole lot there. So 70 equals 5 VF minus 10. Bring that negative 10 over, we have 80 equals 5 VF. Divide both sides by 5, and you get a final velocity of 16 meters per second. That's it. Okay, so the graph is not that bad, but I wanted to do more detailed one than the review because I wanted you to have a little more practice on that. So if you have these equations written down, so mainly this one right here and this one right here, you should be pretty set on this graph. Okay, so now we'll actually kind of go back to the review. Okay, and before I do that, I'm going to go ahead and erase this real quick. And I'm going to talk about the conservation of momentum. Okay, give me a second while I erase this. So if you need these again, just go back and you can rewind. Go back to the beginning of the video and it's all there. Okay, so I'm going to explain the conservation of momentum. You have 3 options. Okay, 3 scenarios. And I'm going to make these more simple. If you want to do the chart from the notes and stuff, the tables and stuff, that's fine. If that's what you want to do and you're comfortable with that, go for it. I just use these 3 equations. It's simpler for me. So, scenario number 1. Okay, this is where you have something that's separate. Okay, in the beginning. Okay, so you have basically, this is where you have like a ball and another ball that they're separate, doing their own thing in the beginning. Then a collision happens, and they still stay separate in the end. Oops, let me fix that. Okay, so that means they didn't stick together. So like a ball and a ball hit each other and they go their own way. Okay, so this is the equation you use for that scenario. It would just be mass 1, V1, initial, plus mass 2, V2 initial. Okay, they're doing their own thing. They hit. And then in the end, they're still their own thing. So M1, so mass 1, still mass 1. But now this is mass 1, V1 final, so final velocity, plus mass 2, V2 final. Okay, so there's scenario number 1 is if they're separate in the beginning and separate in the end. Okay, so they just hit each other and went their own way. Then you have scenario number 2. Okay, this is when they're separate in the beginning. Okay, and they stick together in the end. Okay, so they're doing their own thing in the beginning, and then when they hit each other, they stick. Okay, so you're going to look for phrases like stick together. So in the beginning, so nothing different. So we have a mass 1, V1 initial, so it's doing its own thing. Mass 2 is doing its own thing. Mass 2, M2, V2 initial. Now they stick after they hit, so we're going to have a mass total and 1 final velocity because now they're together, so there's only going to be 1 velocity. Okay, so that was scenario number 2. So separate in the beginning, they did their own thing, and then they stuck after they collided. Scenario number 3 is the opposite. Okay, so that means they were stuck together. Bear with my handwriting here. So stuck together in the beginning, and then they separate. Okay, so then in the end, so mass 1 went its own way, so it's got M1 V1 final, and mass 2 went its own way, M2 V2 final. Okay, this is probably the most common one that kind of people get confused on. This is simply like the gun / cannon. Okay, so they basically are together in the beginning, something explodes, and they go separate ways. Okay, so this is just going to be the opposite of scenario number 2. So you have a total mass in the beginning, an initial velocity. Okay, so they're stuck together, and then they separate. So then you have M1 V1 final, so mass 1 did its own thing, plus M2 V2 final. Oop. And I kind of led you into that equation prematurely there. Okay, so stuck together in the beginning, and then they separate in the end. That was my bad on that one. Okay, so we have mass total V initial, and M equals, so then they explodes, and then they go their separate ways. I'll give you a hint. This side is pretty much always going to be 0, because it's usually sitting there doing nothing, and then it explodes. Okay, so now know what we know. We'll kind of start doing our review. So this is the review, page 25, 26. Okay, number 1, we have a 15 kilogram child is running at 3 meters per second when she jumps onto a 4 kilogram skateboard. Okay, so I have 2 masses now. Okay, when I have 2 masses like this, it's kind of a hint that I need to start doing the M1 and M2 thing. Okay, so I'm gonna go ahead and start labeling stuff. So my 15 kilogram child, I'm just gonna say that's M1, is running at 3 meters per second. Okay, so that's gonna be my V1 initial. When she jumps onto a 4 kilogram skateboard, so there's my M2, which is at rest. So that's my V2 initial right there. What is the velocity of the skateboard? So that means what is my final velocity of the skateboard after the child jumped on it? Okay, so they have combined. Okay, so this is a mass total thing. Okay, so that means they were initial. They were separate in the beginning, and then they combined in the end. So if we go back down to our equations, okay, so separate in the beginning and stuck it together at the end. So that means we're going to use this equation right here, so number 2. Okay, so I'm going to bring this back up here. So M1 V1 initial plus M2 V2 initial equals M total V final. Okay, so now we just start plugging in stuff. So my mass 1 was 15. My initial velocity for mass 1 was 3. Plus my mass 2 was 4. And it was sitting still at rest, so my V2 initial was just 0. Equals, so now they're stuck together in the end. So you're going to do 15 plus 4 means I have a total mass of 19 now. And I don't know velocity, so I'm just going to leave it as that. Okay, so I'm going to tidy this up a little bit. So 15 times 3 is 45. 4 times 0 is 0. So this whole left side is going to be 45. Equals 19 VF. Okay, divide both sides by 19. And if I did my calculations correct, you should have a final velocity of both the girl and the skateboard, or child and the skateboard, of 2.37 meters per second. Okay, number 2, so this is the graph equation. So the graph problem, so we already did a lot of practice on this, so this should actually be pretty easy. So they gave me a mass, so I'm gonna go ahead and label that, and I have an initial velocity, so I'm gonna go ahead and label that. And then I'm gonna go ahead and start doing my areas under the curve. So remember a triangle, so the area of a triangle is 1/2 base times height, and the area of a square or rectangle is just base times height. Okay, so I have a triangle that has a base of 3 and a height of 6. So 3 times 6 is 18. Half of that is 9. And I have a square from 3 to 5. So a base of 2 and a height of -4. So this is going to be -8. Okay, A, what is the change in momentum of the object from 0 to 6 seconds? Okay, so remember, if it's impulse momentum, all it matters is the area under the curve. So for the first 0 to 6 seconds, just combine them. 9 minus 8 gives me 1. You can do newtons times seconds, kilograms, centimeter per second. Okay, either way, you're good. So there's my momentum for the 0 to 6 seconds. What is the velocity and acceleration? Okay, so velocity, remember we do this. P equals m times vf minus vi. Okay, from 0 to 6 seconds, my p, we already figured that out, was 1. My mass, they already told me, was 0.5. VF, I don't know. And they told me my initial velocity was 5. Okay, so I'm going to clean this up a little bit. So 1 equals 0.5 VF minus 2.5. Okay, I'm going to bring that negative 2.5 over. It becomes positive, so this becomes 3.5 equals 0.5 VF. Divide both sides by 0.5, and you get a final velocity of 7 meters per second. Okay, so there's my velocity. So my final velocity is 7 meters per second. Acceleration, remember this was just A equals F divided by M. Okay, so at 6 seconds, that means I'm right here. So if I look over to the left, I have a force of 0. My mass, they already told me, was 0.5. It doesn't matter even anyway because my force is 0. So that means I have an acceleration of 0 meters per second squared at that moment. So acceleration equals 0 meters per second squared. If I were to ask you what was the acceleration at 1.5 seconds or 2 seconds, you would just use the force of 4 right there. Or if I asked you what was the acceleration at 4 seconds, you would use the force right here. Okay, so there's your graph. So if you want to go back to the other page to kind of get more practice on the graph, you can use that. Number 3, I have a 5 kilogram object moving with a velocity of 2 meters per second to the north, collides with a 4.0 kilogram object moving to the south at 6 meters per second. Okay, so I have 2 masses. Okay, I'm going to go ahead and read it, continue reading to determine which one we're using. So find the velocity of the 5.0 kilogram object after the collision if the 4.0 kilogram object is moving to the south after collision at 1 meter per second. So we have 2 separate objects in the beginning and we have 2 separate objects in the end. It didn't say anything about sticking together. So if we go down to our equations, if we were separate in the beginning and separate in the end, we're going to use this as scenario number 1. Okay, so I'm going to kind of write this over here to the side. So M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. Again, if you want to use the table or chart, that's fine, but this is just the kind of the way I do it. I just like to see the equations. Okay, so now we're going to go ahead and start labeling stuff. So I'm going to go ahead and say this 5.0 kilogram mass is M1. It's moving with a velocity of 2 meters per second. So there's my V1 initial. Okay, and I'm just going to go ahead and clear this up just so we don't get things mixed up. Rewind that if you need to see those answers again. To the north, okay, so this is where you got to be careful. You got to watch out for directions. Okay, I have north. They were saying north and south. So you need to pick one to be positive and one to be negative. So I'm going to go ahead and say north is positive. Collides with a 4 kilogram object, so there's my mass 2. Moving to the south at 6 meters per second, so it's moving south. I'm going to say south is negative. Let me clear that up. So south, I'm going to say is negative. And I have V2 initial right here. Find the velocity of the 5 kilogram object. Okay, so here's my mass 1 again. So that means we're looking for V1 final. After the collision, if the 4 kilogram object, okay, so there's my mass 2 again, is moving to the south. So watch out for those directions at 1 meters per second. So that means my V2 final is right here. Okay, so we're going to start plugging things in. So M1, so I'm going to kind of see if I can fit this through here. So M1 is going to be 5. It's moving to the north at 2 meters per second. So my initial velocity for M1 is 2 plus my mass 2, which is 4, is moving to the south at 6. So I'm going to make this a negative 6. And let me move this out of the way so we just have some room. Okay, they collide, and they're going to stay separate. So M1 is still 5. But I don't know the velocity of that 5 kilogram object, so I'm going to leave that as V final. Plus my mass 2, still a mass of 4. And now its final velocity is still to the south at 1. So that means it's still going to be a negative 1 because it's moving to the south. So we're going to clean this up a little bit. So 5 times 2 is 10. Plus 4 times negative 6 is negative 24. So this whole left side becomes negative 14 equals 5VF minus 4. Sorry. I bring that negative 4 over, it becomes positive. So this side becomes negative 10 equals 5VF. Divide both sides by 5, and you get a final velocity of negative 2 meters per second. Okay, so again, just make sure you're paying attention to if they are sticking together. You'll actually read phrases that say stuck together. So if it doesn't say anything about that, okay, you're going to use that scenario number 1. Also, you have to be careful for directions. If they say north, south, east, and west, you have to make sure one is positive, one is negative. Otherwise, you're going to get wrong answer. Okay, here's our gun problem. So gun problem is instantly scenario number 3. So this is our last scenario. So I have a 3 kilogram gun, fires an 11 gram bullet. After the explosion, the bullet is moving at 300 meters per second to the east. What is the recoil velocity of the gun? Okay, so this is where we have the M total, V initial, equals, they go their separate way. So after the explosion, they go their separate way. So M1, V1 final plus M2, V2 final. Okay, so first of all, I have an 11 gram bullet. I can't have grams. So 11 divided by 1,000 is going to give me 0.011. So in the beginning, we have a total mass. So 3 plus 0.011, give me 3.011. Ultimately, it's not going to matter because your initial velocity is going to be 0 because it was just sitting there doing nothing. Then it exploded. Okay, so this is where that 0.011 comes into play because if you leave it as 11, that's not going to be correct. So I'm going to say mass 1 is going to be the bullet, so 0.011, and it's moving at 300 meters per second to the east. So I'm just going to leave that as positive. I'm not going to make it negative unless I have to. Plus my mass 2, which is my gun, so 3 kilograms. And we don't know the velocity, so I'm going to leave that as VF. So I'm going to bring this over here. So 0 equals 0.011 times 300, okay, is 3.3. So I'm going to go ahead and just simplify that. Plus 3 VF. Okay, I'm going to bring that 3.3 over. It becomes negative. So negative 3.3 equals 3 VF. And if I divide both sides by 3, I have a final velocity of negative 1.1 meters per second. Okay, so it's okay that it's negative because the bullet's going east, and then when a gun recoils, it goes the other way. So it's going to be a negative velocity. Number 5, what is the impulse momentum theorem and how are force and time related? Okay, impulse and momentum theorem is basically stating that they're equal. So impulse is the same thing as momentum. Okay, so impulse, which was J equals F times T, so J equals P. So that's the same thing as saying F times T equals mass times change in velocity. Okay, so that's basically how we get that equation, because since basically they're the same thing. Now this question right here is probably the number one thing we get students confused on, is how are force and time related? Okay, so we have J equals force times time. Okay, when we stop something, okay, impulse is always going to be the same. So impulse does not change because we're still stopping something. So this is why cars are designed to crumple. So crumpling car. Okay, so our main factors are force and time. So when a car crumples, it increases the time to stop. If we increase time, that means force has to go down. So the car is going to feel basically less force. If we decrease that time, basically mean we're stopping you sooner, your force is going to go up. Okay, so this is basically why when you had old cars, they were made out, like the steering wheels were made out of metal, and you didn't have airbags. Okay, so that means if you got in a wreck and you hit that steering wheel, you had very small time to stop. You were stopped basically in an instant, which meant your body felt all of that force when you hit that steering wheel. Then, when we actually started making steering wheels that weren't made out of solid metal, and you actually started putting in airbags, airbags increase your time to stop, so you feel less force on your body. Okay, so which means you have a more likelihood of surviving because you're feeling less force. So same reason why gymnastics and cheerleaders and tumblers do a lot of their stuff on mats. Okay, if you were to slam the ground on concrete, the time it takes to stop you would be very small, so you're going to feel a lot of force. When you fall like on a cushion or a padded mat, you increase the time it takes to stop, therefore you feel less force, so which you're able to hop back up and try again. Okay, if you were to fall on your face on concrete, you're a lot less likely to get up and try again. Okay, so that's kind of how you answer that question there. Number 6, last question. Okay, so let me kind of clear some of this stuff out of the way. I don't think I'll need all this space, but just so you don't have to see this while we're going over that. Okay, this question right here, I'm going to go ahead and start this because a lot of people get this question wrong just because they don't know how to put the correct sign on the velocity. Okay, so I have a 0.145 kilogram mass, so there's my mass, is moving at 25 meters per second, so there's my V initial, and is hit back at 40 meters per second. So key word there is back. So that's my final velocity. So that means my final velocity is going to be negative. Okay, if you do not see that, you're going to get the wrong answer. So determine the impulse of the ball. So even though impulse is J equals F times T, impulse is J. J is the same thing as P. And since I have a mass and two velocities, I'm going to use this equation. P equals M times VF minus VI. Okay, so don't worry if you're reading impulse and you're like, well, I don't have force or time. Okay, impulse and momentum are the same thing. If I have mass and two velocities, just use this equation. So P, I don't know. My mass is 0.145. Okay, my final velocity is a negative 40, not a positive 40 because it was hit back. Okay, so this is probably the number one question we get wrong just because people forget to put in negative on that final. Plus, my initial velocity is positive, so just put that as 25. I'm sorry, oops. That kind of deleted everything. Okay, so negative 45, and this is still minus your final velocity, which is 25 meters per second. Okay, so I'm going to kind of clean this up. So P equals negative 0.145. Okay, and negative 45 minus 25 is going to give you a negative 65. So if you didn't get negative 65, chances are you didn't put the correct sign in there. So just multiply those two, and you get a momentum or impulse of negative 9.43 kilograms times meters per second. Okay, so that would be my answer there. If the ball and bat were in contact for 0.05 seconds, so I was given time, calculate the force. So force is a question mark. So we're looking for force. So F and T, so that means we have to use this equation here. J equals F times T. Okay, so we just found impulse slash momentum was right here. So that means we're going to bring this down here and set it equal as J. So negative 9.43 equals your force, okay, which I don't know. I'm going to leave it as F. And then T is 0.05 seconds. So divide both sides by 0.05, and your final answer should be negative 188.6 newtons. Okay, so hopefully this video kind of helped out. Rewind it where you need to, and then let us know if you need anything.